Right, welcome back to the parent effect. It's been a while, but I wanted to do this video because some of my students were asking about this question. It's actually last year's exam, the 2024 paper, and it's version 3, so November 2024. As you can see, it's about a curve which has k's and x's and y's, so it feels straight away quite a difficult question. I wanted to chuck it on Desmos for you first, just so that you kind of have an idea of what the question's even talking about. K is a constant, so we don't know what K is, and throughout the question, K has different values. So I've drawn it over here, and you can see I've given K a slider. And basically, as K changes, so does the graph. So we can see it have more of a turning point when K gets higher, like that. So let's have a look at this first question, which doesn't require us to know anything about K. And actually, it's not too bad as long as you just stick to what you know about differentiating. Okay, so the first question there, dy by dx, that's just differentiating once. So we're just going to do, I'll just put y dash just because it takes less time than dy by dx. When we differentiate, we multiply by the power and take 1 off the power. It doesn't matter if there's a k there. K is a constant, it's not a variable, so it's just going to be multiplied by the power. So we're going to get half k, take 1 off the power, so a half minus 1 is negative a half. 2 times negative 4 be 8, so we've multiplied by the power. Take 1 off the power will just leave us with x to the 1. The 2 will disappear. Why? Because at the moment it's x to the power of 0, and 0 times 2 would give us 0, x to the negative 1, effectively making it not matter. So that's our first derivative. This one here is the fancy way of doing our second derivative, which just means we differentiate again. So I'm going to put y double dash because, again, I'm a little bit lazy. So you're going to multiply by the power. That k is still just going to be there because it's just, if it was 2, it would just be multiplied by it. Take 1 off the power, so I'm more than welcome to do that on a calculator. Negative a half minus 1, we're going to get negative 1.5 or negative 3/2. And this one, we're thinking of this as having a power of 1. So multiply by the power, take 1 off the power, would get x to the 0. So effectively a constant. And they're just going to give you 1 mark for each of those correct ones. Now, by all means, put them in decimals. If you prefer decimals, doesn't make any difference to the examiner. They're just looking for any equivalent statement. Okay, so we've done the first part, which was really just their way of helping you to do the second part. So the second part says, find the coordinates of the stationary point and determine its nature. So part of what you're going to have to do is actually recognize what these statements mean. Coordinates, so we're looking for x's and y's, and it's probably going to have 1 or 2, we're not quite sure. Actually, no, it says here stationary point, so that means that there's going to be only 1 answer, which helps us, okay, because we know we're expecting 1 answer. Stationary point is another way of saying turning point, maximum point, minimum point, all of those things. It happens when the gradient is equal to 0. That's why we call it a stationary point, because the gradient is essentially stopped at 0. Determine its nature. Fancy way of saying, is it a maximum or is it a minimum? What technique are we going to use? We're going to look at the second derivative. So both of these things are referring back to part A. So let's have a look at finding the coordinates of the stationary point. All we have to do is set our equation from above, that first one, equal to 0. Now, they told us that k was 2, so that's going to help us. So I'm just going to tidy that up slightly because I know a half times 2 is 1. And this is where some of my students got stuck because they weren't really sure how to deal with that negative indices. What I tend to do, it makes more sense to me, is if we put it on the bottom, because negative means essentially x to the negative half is equivalent to 1 over x to the positive a half, which is the same as 1 over square root of x. So I'm going to chuck it back on the bottom. I don't mind if you put it to the power of a half, whichever. And at that point, I'm going to multiply everything by root x because I want to get rid of the root x on the bottom. So then I end up with 0 is equal to 1. What on earth is x times root x? Well, this is where indices might help us. It's the same as that. Add the powers, 3/2. Let's tidy it up. Oh goodness, we've got some leftover working. So move the 1 over, -1. Divide by -8. And then we have to undo this. Up to you how you want to do it. I would just go 1/8 to the power of 2/3. You can think of it as if it's x to the half and you're wanting to undo it, then you obviously square it. And if it's x to the 3 and you want to undo it, you cube root it. So essentially you're going to have to cube root and square. Okay, so you could do that separately. I've kind of done it in one go here. And when we work that out, you get x is equal to 1/4. Cool, we know x. That's really helpful. But we need to know y because it said we needed to know the coordinates. So we're going to substitute x equals 1/4 back into the original equation right at the beginning up here. And if we substitute y into that, so into this equation, but we need k to be 2, we'll get 2 3/4. Lastly, we have to determine the nature. So we need to look at the second derivative when x is 1/4. And I can't remember what the second derivative is, so it's a -1/4 k. Oops. And then it was x to the -3/2 minus 8. Okay, so we know k is 2, and we know x is 1/4. And when we chuck that into the calculator, we will find that y double dash is less than 0, which is considered a maximum. And that's all you need to do. You don't actually even have to work out what the second derivative is in order to get that mark. Okay, so the second part of the question, which I think is probably the hardest, let's be honest. If we look at the question, it says points A and B on the curve have coordinates 0.25 and 1 respectively. I've kind of drawn it over here. So I was like, well, that's roughly 0.25. And this is roughly 1 here. And so I've drawn the tangents there. And then apparently they intersect at 0.6. And they want us to find out what value of k that happens. So the problem with this is that we're going to have to do everything, but we're going to have to keep k there. Okay, so the very first thing I need to know, and I always say this to my students, if I'm trying to find an equation of a line, I need to know 2 things, a point and a gradient. Now, I kind of have those things, but I have them in terms of k, and we're just going to have to persevere with that. So first of all, we're going to try and find out the equation of the first tangent, this one here, when we know that it occurs when x is equal to 0.25. We don't know y, and we also don't know k, okay? But we do know a formula for the gradient, and we can use that to help us work it out. So the first line of working that I've done, all I'm trying to do in this section is trying to find out what the coordinate of y is, okay? So I've got x is 0.25. I don't know y, okay? But I know an equation for y. I've got it up here. This is the equation of the curve that we're looking at from the very beginning of the question. So all I've done is substituted 0.25 into that equation. So I've put it here and I've put it here. Now, even in this aspect of the question, it's quite tricky because the maths isn't easy, but just chuck it in your calculator and it works out reasonably nice. 0.5k plus 1.75. So I now know that the coordinates are x is 0.25 and y is this expression. Now, I also need to know the gradient. So I'm going to put 0.25 into the equation for the gradient. And again, it simplifies reasonably nicely. So this is what we can call m. Now, depending on what you've been taught, you might like to chuck it into y equals mx plus c. I prefer the equation y minus y1 is equal to mx minus x1. Okay, so in this equation, k minus 2 is going to go where m is. X and y, which are these two bits here, are going to go here and here. So they were your 0.25 and your 0.5k plus 1.75. And I actually just left it like that for the moment. So that's the equation of the tangent at A. It's pretty gross. Doing exactly the same thing, but this time with x equals 1. So we're going to put 1 into the original equation. We're going to pretty it up. And this tells us what y is. So we now know that y is k minus 2. So we can put it into an xy thing. Here would be 1 and k minus 2. We also need to find the gradient. So I did the same thing. I chucked 1 into the gradient formula. And I got this as our expression for m. And then I'm chucking it into y minus y1 is equal to m x minus x1. So again, this is my gradient. I'm chucking it there. These are my points. Scroll over so you can actually see it. Those are my points there. Right, I now have two equations, and apparently they equal each other when x is 0.6. So now I'm going to do simultaneous equations knowing that they equal each other. So I'm going to take each of the equations and I'm going to set them equal to each other. So I took the first equation, which if you remember is way up here, this one here, and I took it down here. And I simply replaced x with 0.6. And then I made it as pretty as I could. Okay, so I put where it's got x minus 0.25 from above, I've gone 0.6 minus 0.25, and that's given me this term here. Then made it as pretty as I could, and I got it to this point here. Then I've done the exact same thing with this one. And where x was, I've chucked 0.6, 0.6 minus 1 is negative 0.4, and I've tidied it up until I got to this equation. Simultaneous equations mean that they're going to be the same at the same point, so the y should equal each other. So I've just made y equal each other, and then we can find out what k is, which was 3. Okay, I hope that helps you a little bit. Let me know in the comments if you want any help with any of the other questions from that November 2024 paper.